So this is a pretty simple design. I'm sure someone has arrived at this before. Essentially what you have is you take a permanent magnet, neodymium magnet, with a hole through the center of it, and you bolt it to the top of your piston. You face north or south up, and you put a spacer to take up the extra room at top dead center so that that magnet doesn't hit the top. The top is going to be a high frequency pulsed electromagnet with north facing down. So every time your piston gets to top dead center and begins to go just past top dead center, a pulse will be sent from that, driving the permanent magnet down, much like combustion does now. You'll have to have it sent to a crankshaft position sensor or a reed switch, hall switch, whatever you call it, then running to 12 volt and then 12 volt negative. Here's what it would actually look like. I started to build one years ago. Now, essentially, you've got your magnet on top of the piston. It's facing north up. The electromagnet is right there. Okay, so every time your crankshaft position sensor or your switch passes the little magnet on here, we begin to go just past top dead center. That's when the pulse would happen. Boom, right there, driving the cylinder down. Now, what I would need to do is make this magnet longer. I want it to send a signal to pulse this magnet for about, I don't know, 15 to 25% of the rotation. And then you can actually cap off the crank case to create pressure inside there, so that would help drive the piston back up. Now that pressure may get in the way, and kind of like friction would, you can also vent the crankcase if you think that's a better way to do it. But it's a very simple design. I'm sure someone else has come up with this somewhere down the line. But that's it. It's an electromagnetic pulse engine. The reason this one didn't work is because I didn't know it at the time, because I'm just kind of winging it. But it's hard to find an electromagnet that is what you call bipolar, which means it has opposite poles on each side. This one puts out south and north on the same face, which attracts and repels the magnet at the same time. Now, the diameter of this magnet is very close to the north inner circle, and I was actually able to make this piston move about 1/8 of an inch just with the magnetic repulsion. Now this is I guess it's aluminum or magnesium piston and everything. Also magnesium block, which is the best thing to use. I would think a steel block would create a lot of friction with the magnetism, you know, kind of dragging the piston alongside the walls instead of letting it float dead center. But that's it. Maybe someone can improve upon this, and I'm pretty sure the pulse magnets and the high frequency switching magnets are able to be souped up, so to speak, for this kind of application. Maybe right now we don't have all the technology to make this work, but I guarantee you if we worked on this, we could run engines with magnets. You know, it's pretty simple stuff, very basic.